Fine, thank you. So yesterday we had a session, introductory session. Just I'll take 5 minutes what we discussed in the last class. Why data engineer? Why data engineer required and role of Azure data engineer. So the differences between a data engineer, data scientist, and analyst. Azure data engineering products or services, job market of Azure data engineer, right? Fine. So we are using cloud like Azure cloud. Cloud majorly utilized for storing, analyzing, and delivering data. So if we talk about cloud as compared with on-premises, right? In the case of on-premises, we need to set up everything by ourselves. We need to set up our own hardware infrastructure. On top of that, OS installation has to be done, purchasing of database licenses, installation of database server, designing database objects. To maintain all this, again, we require separate teams like the hardware team, operating system team, networking team, security team, and database administrators. But here in the case of cloud premises, everything, no need to maintain all this, no need of any infrastructure or licenses. So everything in the cloud environment. So data engineers, by using all these cloud services, they work on the data, they monitor the data and make it structured and useful. Data engineers responsible for smooth data flow from the source to the destination. Data engineers responsible for preparing the data and filtering or cleansing the data, transforming the data and processing the data. On the other hand, right, data scientist and analyst, data scientist in a simple way is going to strategize for the future, recommendations for the future. See, is going to analyze, identify the patterns and recommendations for the future. Is going to perform data analysis, data predictions, data classification, is going to data classifications, data clustering and recommendations. This analyst is like summarizing the past, visualizing the data of the past, summarizing the data and visualizing the data of the past. So the data, for all this, right, data is the main thing. For all these things, data, we require data. So data engineer does all the groundwork for this data scientist and analyst, bringing the data, transforming the data and processing the data as per the business logic. More than 80% of the 70 to 80% of the data analysis work is done by data engineers. Data engineering involves what are the sources of the data, what is the format of the data, in what format, and how to transform and how to process the data, and what is the destination of the data. And why Azure Data Engineer is in demand today, and what are the roles of Azure Data Engineer, right? So I was talking any organization, right? Now, if you see, we are going to see a data scientist and a data engineer is we are going to see. So data engineer, the foremost responsibility, like creating data warehouse for the organization, is going to store the structured and queryable data. So the data is from various sources like new users, old users, existing users, means data engineer structures. Data engineer is going to structure the data, stores the data and monitoring the data, right? And also communicating with the data scientist and the business team to know the data requirement, the business needs. So in data engineer, keep constantly processing the data, analyzing and monitoring the data, and also checks that is maintaining, is sure that the pipeline is always efficient and secure. Is going to create a data pipelines. He creates data pipelines through which the data is integrated through all the phases. Now, make sure that the pipeline is always efficient and secure, right? This is the primary role of a data engineer, right? If you see the other, designing the entire data flow architecture, and mainly like creating data warehouse for storage of analytical data. ETL, extracting, transforming and loading is one of the key tasks of data engineers. Going to extract data from different sources. It's going to pull the data from different sources, transform it and process it, and loading, right? Yes, and after that, further evaluations by the data scientists, data monitoring. So checking whether that ETL is performed in a proper way, and checking whether the data is available everywhere and anywhere where it is required. Data security is also major responsibility of data engineer. The data need to be secure at each step of the process. There should not be any data leaks or data exposures. Collaboration and communication with the data scientists and also with the business team, right? To deliver the data as per the requirement. So they need to have some analytic skills for performing this kind of analysis and automation. Even certain things has to be automated, such like a data extraction process, which requires minimal human, right? So I was just Azure data engineering products or services mostly used, right? Azure SQL, Azure Data Lake. In a simple word, Azure SQL, right? It's a cloud or DBMS for OLTP, day-to-day operation. Data Lake, it's a kind Azure Data Lake. It's a file system, distributed file system with unlimited data storage. Just in one word, I was saying Azure Synapse for data warehouse operations and for big data operations. Data Factory, simply we can say ETL, cloud-based ETL. Databricks, Apache Spark-based data analytics platform. If we talk about streaming, streaming is for analyzing, right, processing, capturing high volumes of streaming data from multiple sources simultaneously. Cosmos DB, like MongoDB, it is a kind of NoSQL database, that is cloud-based NoSQL database. Key Vault, right, Azure Key Vault, yes, to secure, to protect the data in the cloud. So just I said one by one, but just more briefing about this, right? Azure SQL is not for OLTP, it is for cloud or DBMS. It is not for data warehouse. Data lake, you may ask, okay, why these many products required? So this is for if you want to store data in the form of tables. This is for if you want to store data in the form of files. See, generally, okay, files, okay, you can, if today if you see a lot of data, you can see in the form of files, JSON files, XML files, Parquet files, CSV files, right? In this way, different file formats we are able to store. Previously, we used to have Hadoop distributed file system, right? Now Azure Data Lake, it's a cloud distributed DFS. It's a cloud DFS. You can say it is a repository, a data lake, right? Repository. I can say it is a repository of large varieties. Repository for structured, it can store structured, semi-structured, and unstructured, right? Structured, semi-structured, and unstructured. So if you see like XML files, JSON files are semi-structured. Structured, example of structured, right? Database tables are Excel files. Semi-structured like XML, JSON, they're not fully structured, they're not fully unstructured. Unstructured, right? Raw text, text files, raw text, images, videos. Excel files, XML, JSON, raw text, images, videos. So here data, see here data is in the form of files. See here data is in the form of files here. Data in the form of files. No relationship between the files. No relationship between the files. You can, if they are in the form of tables, you can maintain relationships using foreign key or primary key, right? Yes. For example, if you have got some emp.txt file, dpt.txt file, for example, attendance.txt or salaries.txt, if you got. So these are files in data lake. You are going to store data in the form of files. These are the files, but there you cannot maintain relationship between the files. So, but if you have got a tables, if tables such as, for example, orders table is there, sales transactions are there, customers tables is there, and products table. Just you can maintain relationship using primary key or foreign key. So what kind of, see, generally, what is the relationship? What is the relationship? Here, for example, order is there. Order of what? A product. Booked for whom? Booked for whom? A customer. Once order confirmed as a transaction. Yes. Understand here, order is there. Order of what? A product. Product booked for whom? A customer. Once the customer confirmed the sales transaction. So here, if you want to maintain such kind of, so I'm expecting, so you can do a lot of things within this Azure data lake with your files, but what I'm expecting a cloud or DBMS. You may say already we got a cloud or DBMS Azure SQL. That is for OLTP, online transactional processing, not for data warehouse. So I'm expecting a cloud or DBMS, the two for data warehouse purposes, data warehouse. That too I'm expecting parallel processing. That too I'm expecting parallel processing, right? Yes. That is nothing but Azure Synapse Analytics. That is nothing but Azure Synapse Analytics. So I'm expecting, so DBMS, that too for data warehouse purpose. That too I'm expecting parallel processing. That is nothing but Azure Synapse. See, Azure Synapse, right? For data warehouse operations, for analytics, for batch processing, for parallel processing. So here, if you see in Azure Synapse Analytics, here we have a database. We have a database, right? Called Azure Synapse. Azure Synapse SQL pool DB. Simply we say Synapse DB. Simply we say Synapse DB. What is a Synapse DB? What is Synapse DB? Cloud data warehouse. Cloud data warehouse of Azure, right? Yes. Simply, so here for data warehouse operations, for analytics, for batch processing, for parallel processing, we go for the Synapse. So here we have got Synapse DB, cloud data warehouse Azure. Okay, later we discuss in brief about this data warehousing and this big data operations. Coming to this data factory. Simply we are saying it is a cloud ETL or cloud-based ETL of Microsoft. For example, we talk OLTP systems, online transactional processing systems. Examples of this OLTPs. OLTP means Azure SQL is for OLTP. Still other like on-premises like Oracle is, and SQL Server. MySQL, MongoDB. So OLTP systems, Azure SQL, Oracle SQL Server, MySQL, MongoDB, right? Yes. Data warehouse. If you take data warehouse, OLTP systems and data warehouse. Understand here in data warehouse, Azure Synapse. Still, if you heard about Teradata, on-premises, Teradata, Netija, the specialized databases used for data warehouse purposes, Netija, Vertica, specialized databases used for data warehouse, right? So, okay. But where this ADF, where this ADF in ADF, generally ADF doesn't come. It doesn't come in OLTP. ADF doesn't come in data warehouse. Data warehouse. Where do you see this ADF means between these two? Between these two, you can see this ADF. Between this OLTP and this data warehouse. You can see here. Between this OLTP systems and data warehouse ADF, right? Yes. It has integration service. ADF is an integration service. Integration service between OLTP systems, right? OLTP systems and data warehouse systems. Yes. See, generally, if you talk all transactions, where all transactions are stored, generally all transactions captured or stored at OLTP systems, online OLTP systems at database level. How to bring these transactions? How to bring these transactions to warehouse? Hmm? How to bring these transactions to warehouse systems? We have ETL. We have ETL, right? Yes. Already you have idea about, for example, by using ETL tools. By using ETL tools. What are the ETL tools already available? Informatica, Data Stage, Talent. In this way, many are there. Oh, but all these are what? All these are on-premise ETL tools. But I need a ETL. But I need a ETL on cloud. But I need a ETL on cloud. That is what area. That is what area, right? So simply cloud-based ETL, cloud ETL or cloud-based ETL. So using ADF, what you can connect with what? Using ADF, we can connect with cloud databases, non-cloud databases, non-cloud databases, NoSQL databases. Cloud databases, non-cloud databases, NoSQL databases. Using ADF, we can extract the data and we can pump the data from one system to another, right? Yes. So here in ADF, here our working style, here it is ETL only. Here it is ETL. but our working style ELT. E extract transform load, but here ELT. What is that? ELT. Extract, load, transform. But our working style is ELT. Extract, load, transform. ETL. For small volumes of data. ETL for small, like in GBs. ELT, right? For huge volumes of data. For huge volumes, right? Yes. So if you see in TBs or in petabytes, this ELT is the better choice. For huge volumes, ELT is bad. For huge volumes, ELT is bad, right? So this is something about ADF. Next is Databricks. Azure Databricks, right? Yes. First, before going with Azure, what is Databricks? What is Databricks? What is Databricks? Provides a Spark. What is Databricks? Provides a Spark cluster in cloud. In the cloud. Understand carefully. What is Databricks means? Provides Spark cluster in the cloud. First, I'll come back to Spark, but what is a cluster? Simply, we can say like a group of nodes or systems. A group of nodes means systems connected in a network. Connected in a network. We see two types of nodes. Understand here, we see two types of nodes. See, we see group of node systems. In that one will be that master node, well, other remaining all will be the slave node. We see two types of nodes. Driver node or master node. Worker node, right? Worker node or slave node. Yes. Understand here, driver node or master node, worker node or slave node. So one driver will be there, remaining all are slave or worker nodes. One driver node, remaining all worker nodes or slave nodes. Now, provide Spark cluster. What is the Spark? What is Spark? It is a very high speed processing execution model. Processing execution model, which process huge data or big data at a very high rate of speed. So which process huge data at a very high rate of speed. So here Spark features, mainly the Spark features if we talk in-memory computation, first thing like in-memory computation means data storing in the memory, data processing within the memory. That's why we see very high rate, we can see very high speed processing, right? In-memory computation, storage and processing both happening. Supports MPP, supports MPP, massive parallel process. Supports MPP, massive parallel process. Let's massive parallel process means, for example, understand carefully here in Spark, parallel processing, massive parallel processing. You got this is the master node or this driver node. You will see multiple slave nodes. Multiple slave nodes are worker nodes. Multiple slave nodes are worker nodes. Understand here. Slave 1, slave 2, slave 3, slave 4 in this way. N number of slaves or n number of worker nodes. Only one master or driver node. So your data is there. Your data will be divided into, for example, your data will be divided into partitions. Each partition will be stored across multiple systems. That too in the RAMs. That too in the memory level storage, right? In the RAMs. Spark always deals with memory RAM. Your data storage and data processing, everything happens within the memory RAM level, right? That's why you see very high speed. Data is distributed across multiple systems and data is processed by multiple systems parallelly. That's why we see massive parallel process. 1 second. Massive parallel process. We can see the execution of Spark. Spark is 100 times faster. Spark is 100 times faster. Normal disk processing. Spark is 100 times faster than normal disk processing. If you want to see the speed of Spark, see already if you talk, Yahoo has conducted a test to check the speed of different databases. It has taken a table of 100 TB consisting of 1024 columns. Task was sorting. Task was sorting based on 16 columns. Not on a single column. Time taken, right? Time taken. Oracle. Around 3.5 days. MySQL has taken around 6 days. Teradata, a specialized database used for data warehouse, it has just taken just 4.5 hours. Netija, right? Another specialized database used for data warehouse just has taken 3 hours. Finally, Hadoop is mostly used, right? Even Hadoop has got very high speed. Even Hadoop has got very high speed. It has just taken 3.4 minutes. These have taken days of time. These have taken hours of time. These have taken minutes of time. Hadoop has got very high speed, but Spark is 100 times. Already it has got very high speed in minutes of time. Spark is 100 times faster than Hadoop. Then see the speed of Spark. What will be that speed of Spark? Is 100 times faster than Hadoop. Map reduce, we say. In Hadoop, there is map reduce. It is 100 times faster than this map reduce. Okay. So Spark runs on a cluster. Spark runs on a cluster. What cluster? Spark runs on a cluster. with n number of nodes. With n number of nodes. Assume 500 nodes. 500 nodes means 500 systems. 500 nodes cluster. Assume this cluster is worthy processing. It is worthy processing 2 TB, 2 TB of data at a time. 2 TB of data at a time. 2 TB of data at a time. For example, tomorrow your workload increased. Your workload increased. If same cluster used means, if same cluster is used, see generally a train is carrying like 10 tons. Okay, it can go in high speed. If the 10 tons make double 20 tons, the speed decreases. If it is made into 50 tons, it won't even start run, right? So if that volume increases, in the same way, if the same cluster is used, speed goes down. Speed goes down as data volume increased. As data volume increased. So what you need to do? So we need to scale up. So we need to scale up the cluster. We need to scale up the cluster. How will we scale up the cluster? By adding new nodes. By adding new nodes. New nodes. Assume that 100 nodes added. 100 nodes added. Okay, you are added 100 nodes for that. Again after 2 months. Again after 2 months. Again 100 nodes added. So here every time scaling means adding. Every time adding or scaling up your physical data center. Physical data center is a complex task. Understand carefully. Every time you cannot keep on adding, we cannot keep on adding scale up. So that's why I need the same cluster. I need the same cluster in cloud, and that too. And that too with auto scaling, with auto scaling feature. Auto scaling feature. Who is providing this? Who is providing this? Databricks. Who is providing this? Databricks. Databricks. What is Databricks? Spark Cloud Cluster. Spark Cloud Cluster with auto scaling feature. With auto scaling feature, right? For example, if we talk about one more today, my data load. My data load requires 100 nodes. It requires 100 nodes. Tomorrow, data volume increased. Tomorrow, data volume increased. Understand here? Right. It has to be extended 200 automatically. Understand here? It has to be extended to 200 automatically. After processing completed, after processing is completed, Again, it has to revert. Again, it has to revert back to 100 nodes. It has to revert back to 100 nodes. So whenever that load increase, it has to automatically increase, and after processing, again it has to revert back to 100 nodes. This is general data bricks. This is general data bricks. But it cannot, if you talk about general data bricks, it cannot interact. It cannot interact with my Azure storage services. It cannot interact with my Azure storage services. Just now I discussed at Azure SQL, Azure Data Lake, Azure Synapse, Azure storage services. Regular Databricks is not compatible, right, with all the Azure services. That's why, understand, that's why Microsoft and Databricks collaboratively launched a new product called Azure Databricks. Microsoft with Databricks collaboratively launched a new product called Azure Databricks. Okay. What is Azure Databricks? What is Azure Databricks? ADB. I can say it is a Spark cluster. So we'll be discussing about Spark everything in brief, in depth. Right. It is a Spark cluster with auto scaling and compatible with all Azure data storage services. So now ADB can read data from this Azure data storages, right? For normal Databricks, we need to do a lot of other settings. See, this Databricks not only available for Azure, it is also available for ADS and AWS and Google also, right? Databricks also available for that. In Databricks, understand here, who is processing the data? Who is processing the data? Spark. Who is processing the data? Spark. Okay. So Spark is the main execution engine, right? In all these things. Understood, right? So Databricks Spark cluster with auto scaling and compatible with all the Azure storage services. Microsoft and Databricks collaboratively launched this product called Azure Data. So okay, there is still something about Databricks. And previously I was talking about ADF. It's a cloud ETL, right? Cloud-based ETL and Azure streaming, processing high volumes of streaming data from multiple sources simultaneously. Azure Cosmos DB, cloud-based NoSQL. NoSQL means not only SQL. SQL means schema compulsory. NoSQL, no schema. Schemaless behavior. Record to record different number of fields or columns can be maintained. Azure Key Vault, secure key management to protect data in the cloud. Yes, this clear. We'll be discussing majorly our discussion in this course, right? Azure Data Engineer, right? Mainly Azure Data Factory. Already I said it is a zero coding ETL tool. It is a zero coding ETL tool, right? No coding involved, no prerequisite, everything drag and drop. It looks very simple. Developing the data flows, pipelines, creations, everything looks very simple. But for this Databricks, PySpark, some basic Python knowledge, basic SQL knowledge required, everything we'll be discussing. And Azure Synapse Analytics for data warehouse for big data operations. These four things majorly we'll be discussing as part of our course. Apart from that, you will be getting knowledge on this data lake, that is storing files, SQL, Azure SQL Server, storing the data in the form of tables, streaming, and Fabric's introduction, right? So I already said the offerings from my side, you'll be getting each and every session recorded videos, soft copy of this class notes, assignments and tasks, a WhatsApp group for technical discussions, right? Interview questions and resumes, and interactive hands-on sessions. Hands-on sessions means, right, you can do the practical part along with me parallelly. If any error, you can just share the screen so that you can get that full practical exposure on this entire course, right? Nothing theoretical, everything practical. You can just see the course content. Yes. In brief, in depth, we'll be discussing about all this. First, starting with Azure Data Factory. Pipelines, activities, linker service, data sets, triggers, pipeline, organizing pipelines, creating new pipelines, debugging pipelines, publishing pipelines, linker service. Yes. Blob, SQL database, data lake storage, parameters, data sets. What is data set for Avro file binary for all this, right? Yes. Activities. These are the different copy data activity, filter activity, get metadata activity, lookup activity, right? Iterate filter activity for each if condition, switch until triggers, schedule trigger, tumbling window, storage event, custom triggers, integration runtimes, source control. Yeah. Data flows, different data flow transformations, filter, aggregate transformation, union, lookup, group by, pivot, and around 50 exercises we'll be discussing as part of this course. 50 practical exercises, all these things we'll be discussing, right? Okay. Azure Databricks, coming to this, the prerequisites, what are required, like big data, overview of this big data, overview of Hadoop, and overview of this, but Spark, not overview, we'll be discussing in brief. And coming to this Azure and creating Azure Databricks service using this, adding users and groups, creating a cluster. Adding users and groups to the workspace, creating cluster, right? 1 second. Yes, Kishore, just I'm coming back to your queries, creating a cluster from the user interface, getting started with notebooks and right? Mm. Creating and configuring, right? Yes. Clusters, managing clusters, displaying clusters, starting cluster, terminating cluster, deleting a cluster, cluster information, cluster logs. Yes, cluster access control, types of cluster. Yes, types of cluster, right? Yes. And here, yes, Databricks utilities, data utility, file system, library, notebook, secret, Databricks integration with Azure SQL, blob, Databricks handling multiple file format, CSV data, JSON data, Parquet files, Excel files, XML files, ORC, Avro files, Databricks batch processing, historical data load, incremental data load, right? Yes. And Databricks streaming API, right? What is streaming, processing, streaming, handling back records, Delta Lake, workflows, and Azure Synapse also you can see in brief, in depth, we'll be discussing about this, right? So the duration of this course is 3.5 months, I'm saying, right? Yes, Kishore, 3.5 months. So like Databricks and PySpark. So around like 1.5 months, I'll be discussing on this. And this 1 month, this is 1 month. Look, totally like 3.5 months course. In brief about this Databricks and PySpark. So totally it goes for 3.5 months. Yes. And the course fee for this is 15,000. You can check in the chart. A big message is given by this online team, right? Shall we go with some? Yes, yes, Abhishek Guru, right? Yes, I'll be showing one project, right, at the project flow at the end of this. Yeah, 1 second. Yeah. Any queries you got, you can just go with your queries. Just a second. And th- okay. Can you see in the chart a big message is given by the online team? So from tomorrow, we'll be starting with the actual things. From tomorrow, the link is going to be changed. You are supposed to get enrolled for getting the link up to your mails. So everything step by step from the ground level to the advanced level, everything I'll be discussing. So you can see the demo. If anyone missed yesterday, you can see the video of it. Video demo video course content. You can see the contact details of the online team, the payment details, the Google Pay or Phone Pay details, their account details. But most of the students, one more thing, they have given a note. If you have got enrolled, don't forget to share the screenshot of your payment to that mail ID that is provided. DURGASOFT online training. There at gmail.com. Okay, and fine. Yeah, in brief, in depth, we'll be discussing. I said PySpark also in brief, not like overview here. So PySpark is the main thing, main execution engine in Azure Data Factory at the back end. PySpark will be in Databricks, PySpark in Azure Synapse also. PySpark is the main thing. So in all this, PySpark Spark has got a great boom today. If you see, uh, even if you see Azure Data Engineer, a typical, if you have got a good command on this data engineer, right? Azure Data Engineer. So even you can see the salary package also more than any other technologies, right? And in the same way, they'll be expecting that the command or the skills from your side. Yes. And I was just saying in the yesterday also, like job market of data engineer, like most of these companies are just registering themselves on Azure. Like, yes, they're in turn increasing the number of job opportunities for Azure data engineers constantly. Major companies also, this, they want professionals who can work on this Azure and handling this huge data. Even the pay scales also data engineers has got the highest average salary as closely as to data scientists. The two highest paying jobs, data scientists and data engineers, right? Yes, lot of companies, right? If you see Facebook, Intel, Microsoft, Amazon, they're hiring data engineers with the great salary packages. Even tech giants like Apple, Google, Cognizant, Walmart, they're offering high paying jobs to data engineers, right? It's a good choosing this data engineer is a good career where you will be working with data that is mainly like ETL on the cloud side. Yes. So all the prerequisites, whatever I'll be discussing as part of the course, not a worry. Just only one thing, attending the sessions regularly and just interacting in the sessions, doing the practicals daily along with me. You can do it during the sessions. You can do parallelly, immediately completing the task or assignments. Yes, it looks very easy, right? We'll be discussing many working examples, but 3.5 months the course goes. If anybody unable to spend like 3.5 months, will be too long. So parallelly, you can also attend whenever ADF is going on, whenever I start Databricks in any other batch, you can also parallelly attend Databricks so that your time duration will be decreased because Databricks you can understand. ADF is everything drag and drop. Databricks you'll be writing some codes. So you can attend parallelly also. If any Synapse batch also started, you can attend parallelly. You can complete in time because I'll be running multiple Databricks ADF batches. Yes. So you can contact this, right? Yes. What is that? You can just check with this online team, right? Kishore, right? The contact details are given. 4 contact details, right? Yes. They have given their account details they have given. And this phone pay or Google Pay details they have given, right? Yes. So in brief, in depth, we'll be discussing about all this, right? So these 4 components in brief, in depth, we'll be discussing. Also, we'll be getting knowledge on this remaining, right? Things, right? 15,000 is the course fee for all, right? Any other queries you got, anyone? During the session, anytime you can unmute and you can ask the queries. If any errors you got, if anything you got, you can share your screen. Yes. And about this executions, how we can do, we can get the free subscriptions, everything step by step, I'll show you. Yes. Any queries from your side, anyone? So tomorrow the link will be changing to get that link, the paid link, right? To get enrolled from tomorrow, a WhatsApp group. Tomorrow a WhatsApp group will be created. You will be added to the WhatsApp group. From tomorrow, you'll be getting the videos, daily session video. You'll be getting to your uh, Google Drive, notes to your mails, right? Thanks. Any other queries? I'm working professional, sometimes not able to join us. So after time. Yes, immediately today, for example, immediately after 1.5 hours, you'll be getting the session video. You can go through that and attend the next session for a better understanding. At the start of the session, you can ask the queries. Right? Yes. Even if you want to take any break due to some shift change, even you can take a break and attend the other batches also. Okay, fine. So if I'm done with the queries, if there are no other queries, I'm signing off for now. Meet you tomorrow, same time at 6 p.m. Right. Thank you all for your time. Thank you. Meet you tomorrow. Bye. Bye.